Hello everyone, my name is Nitya Rajagopal from Kenturf Technology Solutions. We provide software solutions to the 5G mobile network, especially for the 5G domain. Today I'm going to show you the live demo of Free5gc core using the Ubuntu Linux VM virtual machines. So those who doesn't know what is Free5gc, Free5gc it's an open source community focused on developing the 5G core network. A lot of talented engineers contributed around the world. So here is the platinum contributors, and then the gold members, and then the silver members. So it's very reliable open source, whatever I found it. Okay, so this is the basics of 5G network. So in 5G network, you have three major elements. One is the UE. UE, it's nothing but your user equipment, your mobile phone or your IoT devices, any devices which is able to receive the 5G radio waves. Then you have the radio access network. So that's in 5G world, it's called as G node B. The G node B basically it is transmitting the 5G signals. Then the G node B will be communicating over to the 5G core. The 5G core in this diagram I split it into two boxes. One is the control plane, the other one is the data plane. Technically you can have both in the same, but in a real good practice it is better to have the user plane function, that is your kind of your data plane. It's closer to the on premises, and this control plane, all your control functions like your AMF, SMF, your PCF, your database, everything will be coming into the control plane. That you can host it in the cloud, or if it is a larger private network you can host it on premise as well. And this UPF, it's directly connected to the internet. Now once the data path is established, the data path will be following this way from UE, G node B, UPF and the internet. This is the data path. Okay, so this is general about the 5G network. Now let's look into what my setup. So this is what my setup looks like. I am running three virtual machines on the Windows. My physical machine is running on the Windows 10. It is a high-end i7 and 32 gig RAM onto this, and I spun into three VM. So the VM1, it's nothing but our UE RAN simulator, and then the VM2, it's running on the 5G core, that's the control plane, and then the VM2, it's running on the UPF. So the VM2, it's I installed all the core functions into the Docker containers, and the UPF, it's like it's just running on only one function directly running on the VM. And the UE RAN simulator, it has two functions, G node B and UE, both running on the same VM. It's not running on the Docker. Now if you look into that closely, so this UPF machine is the only one has the internet access. Rest the control plane, that is the 5G core and the UE RAN simulator doesn't have the internet access. So today our goal is we need to establish the 5G communication between the UE, G node B and then the control function, and then the data path will be going via the UPF. You will have the internet access from this UE machine to the internet. That's what we are going to show today. Okay, now so this is my Oracle VM. So the first one, first let's start with the UPF. So this is my UPF. So what I'm going to do, I'm going to start my UPF function. So today I'm not going to explain about how to install the Free5gc core. Maybe that will be a separate session. Okay. Okay, so now I'm starting my UPF function first. So now UPF function started. UPF IP address, it's 192.168 192.168.56.102. So this is my UPF reference IP address. Next, I'm going to start my core functions. So I already installed the Free5gc compose and using the Docker container, and I have not installed the Kubernetes. Instead, I use the Docker compose. So what I'm going to do, I'm just simply starting the Docker compose. Okay, now you can look into that. You have the MongoDB, it's getting started. The web UI, it started. NRF and AMF, UDR, all the functions, it's getting started. Good. Okay, so now, and you can also see that when this core it's getting started, it's establishing the handshake between the UPF. Basically, the SMF and the UPF, will establish the handshake. You can see that handle PFCP association setup request. Okay, so now the next step. So now, so this one, it's established. Now we can add the UE. So basically, if you want to add a new subscriber, so the web UI, it's running on the port 5000. I already added that one of the subscribers over here, but for your understanding, I can delete this, and I'm going to add the new subscriber. Let's use the same, PLM and ID and the K factor and the operator code. I'm just changing into OP, and so rest all same, but technically I don't have the different slicing right now. I have only one the standard, like the internet. So what I'm going to do, I'm going to remove rest all the. Okay, so I'm just keeping only one simple slicing. So just submit it. So the next, what I'm going to do, I'm just going for my UE RAND simulator. So this nothing but there are two functions inside. So the first one, the gnode B. So the first, what we need to do, we need to start the gnode B. I'm just starting my gnode B. So the gnode B, it's established the connection to the AMF. You can see this communication. See, look at that. See, it's the gnode B, it's contacting the AMF. So using the SCTP request, and it's connecting over the port number 38412, I guess. Yeah. Okay, so it's established the connection. Now, and before that, just look into that the IP address, how it looks like this machine. There is only two interface. Okay, this is the loopback, and the other one, this is my VM interface, and there is no tunnel or anything established. Now, as soon as I started my UE simulator, now the tunnel will be established so that this has the internet access. Now look at that. So this tunnel, the connection setup for the PDU session 60.60.0.0.1, it's established. Now if you look at the if config, you can see the UE simulator tunnel. Okay, so that means technically now this UE has the internet access via the UPF function. The UPF function. Okay, so now what I'm going to do, I'm going to just ping Okay, so the reason is because my name server is not resolved. I'm just going to add the etc resolve.conf. Okay, so here my name server it's showing as loopback. I'm just going to add the valid domain name server. Okay, I have to add the sudo. I'm going to change my and also I'm going to add the default route. All my default route, like I wanted to point it to the newly created interface, so that is the tunnel interface. Okay. Okay, so now you can see that route minus n, I have added the default route. Now if I do ping google.com, I have the internet access, and I can see this. I can go to the internet also, and I can search. Okay, here we go. And to verify whether this session is established or not, we can go to the UPF and we can run the TCP dump. Okay, so look at that. So I'm just running this so I just stop pinging. So 60 now you can capture that. Let's try something else. Instead of google.com, just go to nokia.com. Okay, so you can see that, like, whatever the request, it's coming over here. See, basically, yeah, see, it's coming over here, nokia.com. So that's what. So technically the internet connection is established between the UE to the internet. That's it. It works. Okay, so now just wanted to point out like a few items. So on the configuration file, it's very simple. All you need to do the configuration file. So from here, the Gnode B, you have to mention the AMF interface IP address. Then from the AMF, I mean, technically you are not doing, you are exposing into the Docker, you are exposing the port so that the port will be accessible via the interface, the IP address. Then on the SMF, you need to mention the UPF. Okay, where is my UPF? It looks like. And on the UE, we have to mention what slicing you have to use it. That's it.